Hello, subscribers and new viewers. I'm Michael from Archemy Design. Today we're going to do a walkthrough of a Parametric Fusion 360 file around a specific project. Um, Most of you, if you have a shop or 3D printing area or storage in your garage, you are familiar with these industrial shelves. Uh, 9 times out of 10, for most of us, these are overkill, and they can be expensive. I know you can find some from China. People sell them really cheap through Facebook and other places like that. But if you go to your local hardware store or industrial store, they're pretty expensive and can hold way more weight than you probably need. On the other hand, you could go and make wood shelves. You see a lot of people use 2x4s, which is fine. But even 2x4s are a little bit of overkill when I've done this project in my garage with 2x2s, and which are much less expensive, or you can even just get 2x4s and rip them and even save more money, and they're plenty strong enough. This particular project, I used these galvanized connectors to build this because I wanted to try that, and I saw some of these for sale once at Menards. I don't think they offer them anymore, and it works great. It holds plenty of weight. But it also got me thinking, how can I make a design or a file that's parametric that I can choose the stock wood size I want to use, and then have a consistent bracket that can be used to build these shelves much more simpler and hold plenty enough weight for what might be in a typical application. So that's what we're going to go through today. At the end, in the comments, I will actually share links to where you can get those Fusion 360 files, as well as uh, the STL or the 3MF file for 3D printing. And with that, before we get started, just so you please consider liking and subscribing to my channel. Liking and subscribing will help get this out there so other people can use it. With that, let's get started. All right, so this is the basic design I'm going to start with. The Right now this is just a 8-foot shelf. I think it's 8 by 24 by either 36 or 48. I actually don't remember. We'll check. So this was actually my second iteration. I have another version, and I'll show you the difference of those in a second. But I have another version here that it's a different design on the bracket, which to me, I actually built this one, and to me, the bracket made it a lot easier to build each individual shelf and then attach them. However, it uses a little bit too many fasteners, and probably is easier to, in a sense, level and get square versus this one I have not built, which will require you to pay a little bit more attention to making sure it's square before you attach it. But easier to print, probably less likely to crack or break if you over torque screws versus this one. You got to be very cautious. But we'll focus on this one. I will share both files, links to both files. So with that, let's just take a look at the brackets themselves, um, so we can just get a better view of them and what they look like. So this one, I just call it a basic bracket. It is just basically a, I'm going to call it a triangular shaped bracket with some ribs for support and different holes for attach points depending on the direction you're going to have it. This is a symmetrical part, so you really only need one that you can print for all corners. It's not the case for the other one. The other one has an A and a B side. So, but yeah, this is basically it. And let's look at the other one just in comparison. Kind of getting my direction messed up here. So this went through a bunch of different iterations as well. It basically just has slots where you can put your 2x2s, and this is specifically only designed for 2x2s. The other one we can do different sizes, and I'll show you that. And then it attaches to the support, the main supports. And this has an A and a B, so you can't print this and use it on both sides. You have to print the A and the B. This one takes a little longer to print, actually uses a little bit more material. But, you know, to each his own. I built this one with a little bit different version of this, but it would be plenty strong enough to hold, you know, the weight that you want to hold. As long as you're not putting a whole bunch of really heavy steel and stuff up there, you'd be fine. But let's get back to the main one, because I think this one is actually a little bit better design when it comes to weight and printing. So the idea behind the parametrics of this, and I'll go through how I made it, but so basically once you set up the parametric file, you can go to modify, change parameters, and you have these parameters, and I will walk through these parameters in a little bit more detail. But for instance, right off the bat, you can see I have a lumber height and width. And let's say I want to make this out of 2x4, so I'll put 3.5 and 1.5. And you can see the model automatically updates to be 2x4s instead of 2x2s. And we'll just do one more modification just to give you an idea of what it does. Obviously, we can change the height, the width, the depth of the entire shelf. Keep in mind that there is a difference between the cut shelf width and the actual shelf width. The cut shelf width is going to be a little bit narrower. But here I have that it has 4 shelves. Let's say I want to have one that has 6 shelves. It'll automatically stick in 6 shelves. They are equally dispersed. However, when you assemble it, you could change that however you want. You can make them different heights depending on what you want to do for different areas. So I started with my bracket, and the bracket is just basically a symmetrical design, and just did it in 2D and pretty much built most everything off this sketch, except for when I started to do the ribs and I needed to do some of the other holes. So we'll kind of skip some of that. So just wanted you to see the basic approach to that. And you can just basically see how that was done. There's the ribs. And I know there's a rib function in Fusion, but I don't always use it because when you do a rib, a lot of times you have to do a drawing that has this edge. Well, if you're at that point doing that drawing of that edge, you can also then just extrude that, and that's what I did, because sometimes ribs get funky when you try to do it on different types of geometry that's not perpendicular and things. I always run into issues with that, so you know, there's workarounds to get past those things. Just smoothing it out with some radiuses and fillets, adding my attach holes. And then now starting to make my cross pieces. So at this point, within this, I have done a few things in defining some of my parameters, so we'll go through those right now. Here, I've actually just created the main components of everything that I would need. I'm going to need a vertical support leg, that's the height. I'm going to need support for the frame of the shelf, that's going to be the depth and the width. Those are going to be driven by the parameters as well. And we also have to keep in mind that like I said, the width of the whole shelf versus the width of this could be determined by cut length and things like that. So even once you get the model done, make sure you measure your dimensions before you think about cutting anything, so you know you have exactly what you need. Um, but we're just going to stop right here and let's look at our parameters. So the main parameters that I've created in this are obviously the lumber height and width. It's the cross section height and width of the lumber. In this case, I started with 2x2s, 1.5 by 1.5, so nominal lengths. I defined the shelf height and shelf width and shelf depth as 96, 48, 24 in this case. And when in my mind, when I've done this, I'm looking at the entire cubicle size of the shelf, not the necessarily inset size of this shelf. So we have to keep that in mind that because of that, there might be some different widths that we have to consider here for creating some of the geometry. So with that, I do know that since it's going to be for that depth, it's going to be from the outside face of the shelf to the other side. The cut length of the actual depth of the actual panel of the shelf, or that shorter support that's down here, is going to be -2 the lumber width. So I have this bottom shelf D, and what this is ultimately is going to be a little bit of distance that I want that bottom shelf to be off the ground instead of being flat on the ground, because you got to have space to put your bracket, and you want it off the ground a little bit. So if you need to clean under it or whatever, you can do that. This value is also used in calculating the spacing between the shelves and bringing that top shelf down from the top a little bit. I have a panel thickness of 3/4 of an inch in this design. Since you're using a boxed framed shelf support, you could probably get away with 1/2 inch. It just depends on how deep your shelf gets, if you don't want any sag, but 3/4 of an inch might be overkill. I know with the one that I had in my garage, that's actually 1/2 inch OSB, so it's plenty strong enough. And then I have a parameter for the number of shelves. And let's see, and I'll show you other places where I do calculations and creating the number of shelves and stuff. So hit OK. So at this point, I'm now just joining this bracket in the positions that I want it, as well as these cross pieces. So they're joined, and then creating some geometry for mirroring, and I'm just mirroring and duplicating parts. Putting in the shelf's been joined, and then I just duplicate everything. I just replicate everything. And that last step we're going to talk about. So this is just it's just a repeated pattern, a square pattern, and it's repeating features. So I pretty much grabbed the shelf, the 4 brackets, and these cross members, and I'm just going to repeat them upward based on the number of shelves that I've chosen. And the way that looks is, let's edit that. The way that looks is I'm actually using 2 calculations in this. So in the quantity, I have the number of shelves. I picked the direction I want it to go, which is axis 1 is going to be going up for this one, and I'm not doing any in any other direction, so it's just the number of shelves. In this case, it's 4. And then what I use in my distance for the spacing, and in this case I'm doing extent. I want it to go so far and put so many in between it. Is shelf height minus the lumber height plus the panel thickness, because I need to take those into account. Plus that bottom shelf distance, because I need to also take the distance that bottom shelf is adding to the spacing, and then I subtract 1 inch, and that's just to give spacing from the top down. You could go in there and change that to 2 or to 3, or however if you want to have it further down, it's up to you. But in that case, that's going to just equally space these shelves. So if we just do a measurement between that shelf and that shelf, we got 29.53. We'll do here and here, 29.58. One more time. They're all exactly the same. So that's basically how you create, or at least I created this parametric tool for creating these storage shelves that you can put in your garage, and using materials that generally are a little bit less expensive. Like I said, you could use 2x2s. You could use 2x4s and just rip them and to build this. But you can also do. When I first was playing around with this, I was doing it with 2x3s. I have not tried. I probably couldn't do 1x2s just to try to do 1x2s, because I'm not sure the brackets. The bracket itself isn't necessarily designed for that thin of material. So anyway, that's really it with this video. I will again share some more information down below in the description. And again, please subscribe and like and share this video all you want. And hey, it would be a good project to take on. So I'd love to hear from anybody if you decide to make one of these shelves. Take care, keep building, and we'll see you next time.